Okay, everyone, here is the study guide for rational functions. Let's start here. The binomial theorem can be used to expand an expression in the form a plus b to the n, which of the following is equivalent to x plus 3y to the fifth. So as we expand them, they're going to, this is the fifth power. So we should have x to the fifth, and then we count down. So definitely not a. So x to the fifth, x to the fourth, third, to, yep, that one looks good. We count up with the powers of 3y, so 3y to the 0th, 3y to the first power, 3y squared, 3y to the third, so that's good. And then we need coefficients. So coefficient should be 1, 5, according to Pascal's triangle, 1, 5, something, something, something. So let's see here. 1, nope, no coefficients there, so that can't be it. 1, 4, that's not right. It needs to be 1, 5, so it has to be D. Number 2, the polynomial functional p is given by p of x is equal to x plus 2 to the fourth power. Which of the following expressions is equivalent to x plus 2 to the fourth? So they want us to expand this one out. So the first term is always going to be x to the fourth plus, and then we're going to have so it's the fourth power, so this is going to be 4x to the third times 2 to the first power. So this will be an 8 once it simplifies all the way down. X to the fourth plus 8, so x to the fourth plus 8x to the third, so it's got to be C or D. It looks like all of these are different. The last term is usually really easy to figure out. To figure out the last term, we just need to take 2 to the fourth. So there's going to be a bunch of stuff in between, and then 2 to the fourth over here, which is 16. So it should be C. Should be C. I think there's a weird lighting. Oh, see if that's better. Maybe the shadow fix. Okay. The function f is given by f of x equals x plus 3 to the fourth. When f is written in the form like that, which of the following values is greatest? For this, we're going to actually have to math it out. X to the fourth. So if I expanded this, this is x to the fourth plus 4x to the third times 3 plus 6x squared times 3 squared plus 4 x and then 3 cubed plus 3 to the fourth power. And so when I simplify all these terms, I should get x to the fourth. 4 times 3 is 12x to the third. 3 squared is 9. 9 times 6 is 54x squared. 3 to the third power is 27. 4 times 27 is 108x plus 3 to the fourth is 81. So the highest coefficient, so it's asking which of the following is, these are all the coefficients. The highest coefficient is going to be the one that's associated with x. That one right there, so which is C. The graph of which the following in the xy plane, or the graph of which of the following functions in the xy plane has at least one x-intercept, one hole, and at least one vertical asymptote and a horizontal asymptote. So for this, we're going to need to factor these. Make sure I get this back in frame. We need to factor each one of them. So if I look at a here, it's going to factor into, so x squared minus 16, that is difference of squares. X minus 4 times x plus 4. And then x squared minus x minus 6, that should factor into x minus 3 times x plus 2. So if we need, so we need at least one x-intercept. So this one whole. So this one has. Let's start with asymptotes. So nothing cancels out. So we'll have two asymptotes or two vertical asymptotes, and we'll have nothing cancels out. So 0 holes. So it can't be A. Going down to B, this is x plus x minus s squared minus 16, so that is the same as it was for A. This is x squared minus x minus 30, so that's going to be 6 and 5. So we should get x minus 6 times x plus 5. This one, the same thing happens. Nothing cancels out, so there's no holes, so it can't be B. So we'll go to C, which this is difference of squares again, but now I have a 4 instead of a 16. So I have x minus 2 times x plus 2. And that is all going to be over. That denominator is the same as the one before. So that's going to be x minus 6 times x plus 5. Again, nothing cancels out, so that leaves us with no holes. So it can't be C. It must be D. But just to be thorough, let's go ahead and factor D. And this is what? X squared minus x minus 6. So that is x minus 3 times x minus 2. And then here we would have, so let's see here. That would cancel out with that. So we would have one whole at x equals 2. And we would have 1, this right here, be a vertical asymptote. X minus 3 is a vertical asymptote. Let x equals positive 3. Oh wait, hold on. This should be x plus 2. So I'm just going to switch these two around just to make it. There we go. Now the colors will still match. But yeah, the bottom should be x minus plus 2. One vertical asymptote there. And then we should have one x-intercept at 0, positive 2. So the whole should be at negative 2, by the way. And then pull the intercepts there. That is our x-intercept. So we have one of each. We just need one horizontal asymptote. And the horizontal asymptote, since these powers are, the degrees are equal, both these would have a degree of 2. We should have an x-intercept, or the horizontal asymptote at y equals 1. So it'd be 1 over 1. So it's D. It is D. Okay. Let's go to the back of this page here. Number 5, just skip number 5. That is a very poorly worded question. Okay, number 6. The ancient Pythagoreans studied figurate numbers, which are numbers that can be shown by taking dots or spheres and arranging them into geometric shapes. For example, the square numbers, 1, 4, 9, 16, etc., are, in each of those numbers, our dots can be arranged into a square. The tetrahedral numbers similarly specify the number of spheres needed to create a tetrahedron, which is a pyramid. The tetrahedral numbers are 1, 4, 10, 20, etc. Which of the following statements is true? So it could be best modeled by a quadratic. So the quadratic or quadratic, cubic or cubic. And it's the second difference, third difference. Okay, so that's the difference. We need to figure out if it's a cubic or a quadratic and why. So if we're talking about differences here, we're going to need to do the table. So let's see here. The numbers you're going to use are 1, 4, 10, 20, 35, 56, 84. And if we want the first, second difference, third difference, so we need to figure out what the differences are here. So the difference from here to here is 3, from there to there is 6, from there to there is 10, 15. That one's going to be 21, and then that one is what comes after 21, 28. Yeah. And then find the next difference here. That's going to be a difference of 3, 4. That's a difference of 5. That's a difference of 6. And that's a difference of 7. And then here, a difference of 1, difference of 1, difference of 1, of 1. So the first, second, third differences are the same. Third differences are the same. So that means it's got to be this one or this one. And if the third differences are the same, then it should be a polynomial with the third power. And so it should be a cubic. So D should be our answer there. Also, if you notice that these are the tetrahedral numbers, that's one of the diagonals of the Pascal's triangle. These are the triangle numbers. These are the counting numbers, and then these are the ones. These are all just diagonals of the triangle. Okay, number 7. The rational function f is given by f of x is equal to all of that, x to the k times x minus 1 times x plus 3 over the other polynomial, x to the 5th plus 2x minus 5, where k is a positive integer. For which of the values of k will the graph have a horizontal asymptote at y equals 0? So for a horizontal asymptote at y equals 0, so for this bit right here, the degree must be larger on bottom. The degree is larger on bottom for that to be true. So the degree of, the bottom one is just a degree of 5, so this is a 5th degree. And the degree on top is going to be, well, there's 1 factor, 2 factors, so, and then k factors, and we don't know what k is. So we know the degree on top is 2 plus whatever k is, degrees. And so we should figure out which one of these values keeps the top smaller. So 2 plus 2 is 4, so that one would work. 2 plus 3 is 5. They can't be even. 2 plus 4 is 6. Nope. 2 plus 5 is 7. That's too big. So it must be A. The rational function r is given by r of x is equal to that, and is equivalent to r of x is a polynomial over another polynomial. Which of the following statements are true? And it looks like those answers got cut off to the next page. Okay, the degree of P is less than the degree of Q, so it's looking for in behavior. It's going to be asking about in behavior because these are horizontal asymptotes. So in behavior, so we need horizontal asymptotes. And it also means we're looking at the limit of our function as x goes to positive and negative infinity. So as we go both directions. So, oh, we're good. Okay. So let's figure out what these asymptotes are going to be. So the degree on top, for horizontal asymptotes, the degree on top is going to be 1, 2, 3, so it's a third on top, and it's a 1, 2, a third on bottom. So the degrees are even. Therefore, we do coefficient divided by coefficient. The coefficient on top is 2 times 1 times 1. So it's going to be y equals 2 over 3 times 2 times 1 is 6. So it should be 2 over 6. So it should be 1/3. So let's take a look at what we got here. So 0 is not quite right. Infinity is not right either. 0, again, wait, are these the same? Oh, is equal to. So yeah, they're gonna be equal to. So it's gonna be one of these two, and it's gonna be 1/3. So it's gotta be D. Great. The function h is given by h of x equals that minus that, which the following statements is true. So let's see here. We need to get these two to be a single expression, ideally. That's what these do. So let's do that real quick. If I wanted to, so this is 2x to the third over x plus 3 minus 4 over x plus 1. Or sorry, x minus 1. Now, if I want to subtract fractions, they have to have common denominators. So what I'm going to do is I'm going to snag a different color pin. So what I need to do, I need to get this to be common denominators. The easiest way to do that is just multiply the top and the bottom by, it should be x plus 3, x plus 3. And then on this side, so we'll multiply top and bottom of this fraction like this, and then multiply the top and bottom of this fraction with x minus 1. So when now they're going to have, so this is going to be x minus 1 times 2x to the third, which is going to be 2x to the fourth minus 2x to the third over x plus 1 times x plus 3. So that makes that denominator x plus 1 times x plus 3. And then we're going to subtract 4x plus 4 times 3 is going to be, sorry, wait, so this should be x minus 1. Sorry, x minus 1. Making the same mistake over and over again. 4x plus 12 over x minus 1 times x plus 3. So now these are common denominators, which means I can merge these two here. So we should get 2x to the fourth minus 2x to the third minus, so we got to distribute this negative here, minus 4x minus 12 all over x minus 1 times x plus 3. So get them to common denominators, and now you can make them one fraction. So let's see. H is equivalent to 2x to the fourth minus 2x to the third minus 4x minus 12 over, oh, if I distribute these, I get x squared. Add these two together makes a positive 2x, and then multiply negative 3. So, okay, great. So it should be that once I multiply these together, this is equivalent. This is not equivalent. I'm not sure about that. I'd have to do some math, but I don't think that's right. And then this one, no, the bottom is way off there. So this is the equation we're equal to, so that's a contender. The same in behavior as the graph of 2x squared. So I have a degree of 4 on top, a degree of 2 on bottom. If the degree on top is bigger, it's the dominant one, so there is no horizontal asymptote. So the end behavior is going to go to infinity, which means it's going to follow the even one here. So, yep, 2 extra, so it should be A. Okay, I'm going to pause it there, and I will start the next video.